I'm a game changer. I'm a risk taker.
Hello judges, we are Team 𝗖𝗄𝗋𝗄𝗏 from the School of Science and Technology Singapore. Our team consists of 4 members. All are experienced in competitions that are similar in nature. Firstly, let's introduce the team members. Andy and Jovan are the main team builders that construct the robot, whereas 𝗘𝗚𝙗 and Shanjith are the main programmers. We are a group of 15-year-old students that came together as a group in early 2021, and we decided to take part in this RoboCup event. From our years of knowledge of competing in LEGO competitions, we leveraged this to our advantage in this RoboCup competition. Our school, the School of Science and Technology, SST, has a naming rule where all team names had to start with the prefix 𝗖𝗄. Hence, our team name is 𝗖𝗄𝗋𝗋, as ohms is the unit for resistance, resistant towards any challenges in our way. We have collated a record of the days of our RoboCup journey. We hope that you can enjoy this notebook and be a part of our learning journey together. Now, let me talk about our robot. This is our robot, joules. It is named after a unit of energy that follows the SST's trend of naming units of our work. Our robot is capable of line following accurately. It also scans for obstacles, collects balls efficiently and stores them, dispenses them, and collects balls. Our robot consists of an EV3 ultrasonic sensor, 2 EV3 light sensors, 1 EV3 medium motor, and 3 EV3 large motors.
When it comes to hardware design, we aim to make sure that the weight of the robot will be evenly distributed throughout the body and that the center of gravity is near the ground. This is to minimize any effects that uneven weight distribution has on the turning and line following of the robot, and that the robot will not topple over when going over an obstacle. Next, we decided to use an intake system that constantly spins and the ball that comes in contact gets rolled up into the collection area. For dispensing, we have arms that close in from the side of the collection area, pivoted at the corners, and forcing the balls out when it turns. We also mounted the ultrasonic sensor vertically so that the ultrasonic sensor is able to detect rounded objects such as a water bottle, which could be potentially used as an obstacle during the official competition run. This is because rounded objects might cause the wavelengths from the emitter of the ultrasonic sensor to bounce away from the rounded surface of the object, and the receiver of the ultrasonic sensor will not receive any input at all. Should the ultrasonic sensor be mounted horizontally instead, there is a higher chance that the wavelength will not be received by the sensor compared to when it is mounted vertically. We positioned the ultrasonic sensor in front of the intake system so that it is more efficient and saves more time during the run. As a result of this position, the robot will be able to detect the balls and can just move forward to collect the balls, instead of having to do any additional actions after sensing, which would waste precious seconds during the 2-minute run. The light sensors are directly centered between the motors to ensure that when the robot is turning, the robot is able to turn in both directions, left and right, equally. Furthermore, the sensors are placed close to the motors to reduce the amount of distance the sensor covers when the robot turns a little bit. This allows the robot to line trace more accurately and precisely.
Now, as the coder, I'm going to talk about the software design of the robot. Alright, let's start from the beginning where we define our movement motors, recalibrate our color sensors, and define the values for the variables, like the intensity of the colors green, as there might be different lighting condition and we can easily change the values accordingly. Next up in the code, the robot is going to do line follower until the ultrasonic sensor detects the obstacle in a 5 cm range. Breaking down the line following code, if the left sensor detects any colors other than black, then it will check whether the right sensor detects any other colors than black. If so, it will move forward as it means that the black line is in between the two sensors. If the right sensor detects black and the left sensor detects any other color than black, the left wheel will move forward and the right wheel will move backward, resulting in the robot turning right. If the left sensor detects black and the right sensors detect any other colors than black, the right wheel will move forward and the left wheel will move backwards, resulting in the robot turning left. If both sensors does not detect any other color than black, then that means it is at a junction, so it will move back to check the condition of whether there is a green box. If the green box is detected on the left sensor, then it will check if the green is on the right too. If not, it will execute a block of code accordingly. If there's a green on the right sensor, then it will check whether there's a green on the left too. If not, it will execute a block of code accordingly. Here is the movement of the specific block it will move. So now we are going to show how it will look like according to where the green box is. After detecting an obstacle, it will execute some movement to maneuver around the obstacle. After that, it will continue line following until both color sensors detects red or any other color that we can change accordingly to the entrance of the evacuation zone. And then it will execute the evacuation zone program. So how the logic work of that is that when it enters the evacuation zone, it will turn 90 degrees left and move forward. The two possible outcomes is that it finds the box to dispense, or it meets the corner of the line of the evacuation zone, which is not white. If it's not the box it meets, it will turn 90 degrees right and continue the same for the three other corners of the field. When it meets the box, it will go in a zigzag movement while collecting the balls, and it will return back to the dispensing box and dispense. Afterwards, it will go around the line of the evacuation zone using single line following to search for the color of the exit. However, due to COVID restrictions, we did not manage to have a recording of the whole field movement, but here is how the collecting and dispensing system works. After all that, it will continue line following to a red line, which is the exit line. And that's all for software design. Up next is design process.
For the design process, we gathered the opinions of the other teams and took some inspiration and ideas from their strategies and robot build. Also, we asked the trainer for advice at times to see what he thinks of our robot development and the code's algorithm. In addition, we also went online to research on robot designs from past competitions, and we developed the main body of the robot from these different ideas. After completing the main design of the robot, we made modifications to the robot to make it function more smoothly and reliably. For example, adding rubber bands to the top of the robot's intake system to fling the ball into the collection system instead of the ball being flung out of the robot. The robot shown below was a basic model that we were planning to build. We used Lego parts to build a prototype robot that enabled our team to test the line following code. As our team felt that the main competition requirement was the line following, we started to work on the code as a first priority. As such, we decided to build a prototype robot before scaling it up. This increased our productivity as a team coder does not need to wait for the actual robot to be built before coding and conducting the line following trial. After the line following code was working successfully, we started to scale up and build the final robot where we conducted the final recalibration and evaluation trials. This is our final robot design. Thank you for your kind attention.